All right, Pablo, we are up.
Okay. Hello, everyone. This is basically, I would say, a presentation, but it's like a summary of the new roadmap. So this has been talked about in multiple offsites and throughout these last 2 months. And me, Ivan, Zoltan, and Sasha, we prepare this small set of slices about the target API and architecture. So let's let's start. So we identify two types of people that might use Waku. Waku is basically a library, so it's not really an app. So it's a node, and it's a library. So you can build applications with it. You can run your own nodes on the server, or you can build applications and run the node at the same time, because your app will run the node. About the node operators is out of scope for this presentation, because basically it's focusing more on application builders, in the sense that if you're a builder, you want to use Waku, you want to know which APIs you can use and what actually Waku does. So we assume basically that we are in Web3 domain, so with all the issues that it entails. So the point of this presentation basically is for builders to know and use Waku in a easy way, as easy as possible. Right now, Waku is not very popular. There might be multiple reasons. An important reason is nobody cares that much about decentralized messaging anyway. Another maybe that competing projects are already being used for this. And another one is Waku is just difficult to understand and integrate, or we just need more exposure like we are doing now. This presentation will focus on the third issue. It's quite difficult to understand and integrate. You go to Waku, you don't know where to start. So the assumptions here is that convenience over difficulty over complexity. So normally in Web 2, people just go to a web page, read a bit getting started, and if in 5 minutes they don't have some kind of app up and running, they are a bit discouraged. Web3 solutions are a bit complex by design. Everybody knows that Web3 is a pain to deal with. Everybody that try to pay any with their wallet application in their phone knows that it's kind of a pain. So people know that the UX in Web3 is a bit lacking. And in the case of messaging, and it's especially painful in the sense that messaging protocol that is decentralized is quite laggy. Sometimes it might be issues with reliability, and not to mention the issues of the sheer complexity of where to start. So here we are. The goal that we have for this second half of the year is for projects to start using Waku. The focus is twofold. Made the integration easy, in the sense that you arrive to Waku, you pretty much in not very many lines of code, you can go and have your app running. You can send messages, you can receive messages, and all this stuff. And on the other hand, we kind of need to focus a bit on on explaining that it's not gonna work as well as any Web 2 app. I mean, it's a decentralized app. The whole point of Waku is the permissionlessness and the privacy, and that you can trust that something that you run in your computer will not try to steal your data. So as part of this H2, we started thinking about, okay, let's have a bit of history. At the beginning, it's only Waku core or Waku, which has a set of protocols that are kind of difficult to deal with. So we started thinking, okay, let's create another set of messaging API. It's called messaging API or Waku SDK, or on top of this core, in order to be able to use Waku core in an easier way. We started with this suggestion draft, and then we started with chat SDK that goes a bit on top of that we'll talk a bit later. So the system SDKs for now, the competitors are these guys. So XMTP, Matrix, I mean, Polyconnect, not that much, but they all have kind of decent SDKs in the sense that you can see what's going on in 5 minutes or less, which is what we are trying to build. And as we said before, the focus is developers in the Web3 space. I mean, that's the main focus of this presentation. As we were talking before, Web 2 is amazing in the sense that you use an SDK or an endpoint, it just works. It goes to the central server with the central database, and it's amazing. We need to make sure that people that come to Waku, they don't want that. I mean, they want the amazingness, but we cannot provide that much amazingness. It's going to be delays. It's going to be issues with connection in a random node, in a random network. But on the other hand, we have these amazing things that you don't have to ask for permission to create an account. You just create a private public key and you're good to go. Nobody can prevent you from saying whatever you want to say in Waku. Nobody can really stop you from talking to your peers. Nobody can check your network graph, and nobody can spy on you. That's the beauty of it. On the other hand, obviously, it's going to be a bit delays, some messages might be lost, etc., etc. We need to express that. So as we were talking before, we have these 3 layers kind of thing, right? The Waku core, that is the only thing that we were exposing to external contributors and external projects that might use Waku, and it's basically the only thing that internal projects, external projects, everybody uses. I mean, everybody that uses Waku will use Waku core. Our aim is that in the near future, mostly internal contributors will use Waku core. External people or external projects will most likely tend to use an SDK. This is what I was talking about before. The Waku SDK / messaging API. We still don't have a nice name for it, but for now, let's call it that way. It's the layer just above Waku core that provides a bit of things like send receive without dealing with low-level stuff like how do I send through like push, through relay, or how do I receive through filter, through store query, through relay, so stuff like that. And then we have the application SDKs that are more oriented to be used in the near future. Let's go up. And this is pretty much the main kind of slide where you can see the Waku core being low level things like relay, store, like push and filter that probably only core contributors should care about. Maybe when we have other SDKs, people might not even know what these things are or what those mean that much unless you are very interested in the Waku project. So our kind of number for the use of this thing is 1%, mostly core contributor, of external use case, mostly will be used by core contributors and stuff like that. Then we have the Waku SDK / messaging API / something else. We still don't have a proper name for it, but basically it's like send and receive. So if you think of Waku core like relay, store like push filter, store query, hash query and stuff like that, messaging API should be thought of send and receive. How you send, you don't know. Relay by push. How you receive, you shouldn't know at this level, right? You don't know if it's a store, if it's a relay, you don't know how you received. These basically should handle small reconnections, something like, okay, you are offline for 5 minutes, and I reconnect, I get the messages that I miss at this point. We say 14% here, maybe it's more, but yeah, this Waku SDK might be used for external projects. Mostly, it will be used by the new app/chat SDK, and we arrive to the last layer. That is app/chat SDK. In this layer, you can think of send to a group of people, send to one person. Just the chat research lead was calling it conversations. So there is kind of type plus participants. So a bunch of people and a type of conversation. You can think of broadcast, one-to-one, group, stuff like that. So at this level, you can think, okay, send to this type of conversation in the sense of broadcast, one-to-one, group, whatever, and this bunch of participants. One-to-one would be one participant, or group would be more, and receive from any kind of conversation. At this level, we will have something like end-to-end encryption, message grouping, and SDS reliability very tightly coupled with encryption as well. This is what we pretend to be more marketed to external projects and have the most adoption. Ideally, every external project should use one kind of the app SDK. Very little should use the Waku SDK, the second level, and almost none or next to zero should use Waku core. It's not that should, it's like probably they won't use it, basically, because they would like to have extra stuff like end-to-end encryption, reliability, and stuff like that. We are building as well these things in NIM, and they will have the bindings on Go, Rust, Node, and C, and more bindings. Distribution. Okay, this is how we are thinking about distributing this stuff. How whether to compile artifacts or not, or just provide the code. Well, this is still kind of work in progress or open to suggestions, but basically applications as the case out right now, since it's, I'm talking about this high level, it's quite new, so probably a monorepo might be good enough. Probably then we want to move to multiple repo that matching what Waku has, basically. Ideally, we want this SDKs to have an NPM or crates or Nimble or Go package or whatever package manager you have, so you don't even have to go to GitHub to use them. And that's the end of the presentation. if you have any questions, stuff like that, let me know. Although I don't know if I can see the questions.
Any discussion?
Sultan, do you have anything? No specific queries from me. Wondering if Zoltan might have something.
Using me.
Aha, there you are.
Well, I'm here, but actually, yeah, we are ready to answer your questions. Although I think in the morning session we had a great conversation. Nothing really more to add because there are so many implementation detail we don't edit here, and there are of course some known history and artifacts of the current stage where we are with this. And maybe if you can go back to the page of this layered architecture, that this one, I think it was Pablo's idea to add FSDK/JetSDK, because currently different part of the team is working on different layers, and therefore this naming we try to match before the layers. And of course all these layerings are meant to hide complexity and provide easy access to utilize Waku on any level. Actually, we are maintaining two different implementations. One is JavaScript and the other one is NIM, which is obvious for the team, might not obvious for the outer world. And of course, from the NIM side, we plan to provide bindings to different programming languages for the different layers. Of course, in this picture, we left out Waku core, although we have currently this level as mature, but it's in our head to hide somehow a little bit of this level, as Pablo was great to say, that it is really meant to serve as a building blocks for higher level SDKs. If you have any idea or anything to ask here, please come up with.
Yeah, I have a quick question. One of the things that's, I think, made the layer separation difficult is that there's some items in the stack that belong in kind of multiple layers. Like I think segmentation being one of those, where it's kind of particular to the Waku SDK or to Waku in general, because it's needed there. But it also needs to be implemented kind of before encryption or after. There's kind of nuances there. Has there been any thoughts or directions or recommendations about how to handle those items that are a little bit, they need to be in one spot in terms of processing, but really belong logically with another?
In the case of segmentation, it can go quite deep into the core. It doesn't really need encryption in that sense, because you can just segment part of the bytes. As long as you receive them all, you're good to go to recover the main message. And then once the main message is recovered, you will probably know how to decrypt it. But yeah, there was some discussion in the morning about these things, like where to put segmentation. Probably next to Waku core. Everybody might want segmentation. Multiple people that might use Waku core might want to send something larger than 1 megabyte. That's one thing. Rate limiting, very, 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 very tightly coupled with RLN. It should be probably as well in Waku Core. RLN doesn't care about these upper layers, it just cares about actual Waku messages of 1 megabyte. You can send 100 every 10 minutes, stuff like that. And, that's the current. So these two things should probably be there, or very, very, very closely tied to this Waku Core stuff. Yeah, that's pretty much it.
Yeah, I think that makes sense. I'm just cognizant that RLN's entirely based upon how many segments that come out rather than logical messages. So having that impact, is just something that I've been thinking about. I'm not sure I have a question on that matter, but I appreciate your answers.
Maybe to add here, I don't think that all these layerings, when we put every specific item here, is carved in stone. So definitely, I believe it should have lower layers always have support for the upper layers to implement something. So we could have this approach for such more specific features like segmentation and encryption and identity, I would say. So I think it will be the work will be in vertical alignment, that anything is needed for the higher level needs support from the lower layer. We can go deeper and deeper in terms of support or hooks or any kind of dependency injection, for example.
Awesome. Thanks.
Any other questions? Because we are, I think, so many people on this call. No more questions?
Looks like that's it. Thank you, Pablo.
Yeah, thank you. See you. Bye.
Thank you, Pablo, for the presentation and for all coming.